Hi everybody, my name is John Corbett, or as a lot of people know me, Corbettmaths, and today rather than making a video aimed at students, I'm actually going to be making a series of videos aimed at teachers or people training to be teachers or even home educators. And the purpose of these videos is to share some of the lessons or activities that I used in the classroom that I found to be really successful. I sometimes find as teachers that we're quite modest. So if we've had a fantastic lesson, we just think that's great, I'll do that again next time. And we don't go around sharing it with colleagues or sharing it with the world in terms of that was a fantastic lesson that I've done. And I've actually been wanting to create these videos for quite a long time, but actually I've been just being a bit sort of reluctant to do it in terms of I didn't want to come across boastful in terms of, oh, this lesson was really great and I'm fantastic or things like that. But it's just that these lessons I've found to be really great. And perhaps I think if you're teaching perhaps your class or if you're home educator and you're teaching a topic at home, you might find this particular activity or lesson very useful. Now, in terms of these activities or lessons, a lot of them have been shared with me from other people. Some of them you may have heard of before, but I'm actually going to be sharing in terms of the activity or the lesson, what it is, how I've used it in the classroom, perhaps what groups have used it for, perhaps how we might want to take it on further and so on. So a lot of these activities have already been shared with me, and if I can remember who shared it with me, I'll try and share that in the video as well. But also what I'm going to do is share with you lessons and activities that I've designed myself. And I've just thought, oh, this is an idea that I've perhaps designed myself, and hopefully that'll be quite useful for you as well. Okay, so let's start off with our first lesson, our first activity that we're going to be looking at in this series, and that is the 1089 investigation. Now, this investigation has been around quite a long time, and you've probably heard of it. It's one that was shared with me during my teacher training. So whenever I was doing my PGC a long time ago back in the University of Bristol, our two course leaders, they'd done this activity with us. And it was absolutely fantastic. Whenever we were doing it, we had that sort of, whenever we done the activity as a group of PGC students, we had that moment where we were like, wow, this is great. But also in terms of the way they carried out the activity, and they give us in terms of suggestions in terms of how to take it on further. Since then, I've actually used this lesson quite a lot. So what I would do to begin with is, first of all, I would often with this lesson, I would get an envelope. And in that envelope, I would put a big question mark on the front of it. And inside of it, I would write the number 1089, 1089. And I'd put that inside of the envelope. And what I would often do is I'd stick that to the whiteboard. So whenever the students come in, I'd say, okay, guys, we're going to do a bit of an investigation today. I would not call it the 1089 investigation because that would give it away. And what I would do is I'd have that envelope stuck on the whiteboard. Okay, then what I would do is I'd tell the students to pick a 3-digit number where the first digit is bigger than the last. So I'd say, class, okay, I don't want you to show me your numbers, keep it secret, so they're quite often covered up. And I'd say, class, I want you to pick a 3-digit number where the first digit is bigger than the last. So for instance, and I would do this on the board sort of for them to sort of demonstrate, for instance, we can have 613. And as you can see, the first digit is bigger than the last. So the digit in the hundreds column is bigger than the digit in the units or the ones column. Okay, so can everyone do that now for me, please? Okay, and don't show me what your numbers are. And actually, and if you've got a class that you might think they might make a mistake with that, you could actually say to them, okay, guys, what I also want you to do is can you just check the neighbors beside you? You can look at each other's numbers and just check that their number is a 3-digit number where the first digit is bigger than the last. Okay, has everyone done that? Okay, fantastic. Okay, now what I want you to do is I want you to take that number and I want you to reverse it. So if I had this number 613 and I was to reverse it, what would that be? Okay, and you get someone to say, okay, 316, yes, so 316. So what I would want you to do is, can you please reverse your 3-digit number and write it beneath your original one? Okay, so if you had 613, reverse it and write it beneath, and you would have 316. Okay, fantastic. Okay, so you've all done that. Okay, great. Actually, and if you wanted to get to check your neighbors, okay, just check your neighbors and make sure they've reversed it successfully. Okay, fantastic. Okay, now what I want you to do is I want you to take away those two numbers, okay? So I want you to subtract those two numbers from each other, okay? So do subtract. Okay, so I want you to subtract those two numbers from each other. Now what's great about this is whenever they do this subtraction, there's only certain options they can get. They can either get 99, and we'll come back to that in a second because it has to be a 3-digit answer, so we'll get them to make sure there's a 0 in front of that 99. They can get 198, 297, 396, 495, 594, 693, 792, 891, and 990. So there's only certain answers they can get. So whenever you're circulating the class later on to check, if you wanted to check if someone's made a mistake, you can actually spot if they've got the right answer to the subtraction. So that's going to be really useful for you as well. Okay, so let's subtract our numbers. So 3 take away 6, well, we're going to borrow. So it's going to be a 0 and a 13. 13 take away 6 is 7. 0 take away 1, we're going to need to borrow again. So with the subtraction, there's going to be 2 borrowings. So that's going to be quite useful in terms of considering the suitable groups if they're not comfortable with subtraction with borrowings. Perhaps they're not ready for this activity. Okay, 0 take away 1, we're going to borrow again. So that's now 5 and a 10. 10 take away 1 is 9, and 5 take away 3 is 2. So as you can see, we've got the 297. So the middle digit should always be 9, and these two digits should add together to be 9. That's just something that you'll notice with the answers. So hopefully the class have now done their subtraction, and don't reveal that to them in terms of, oh, there's only certain answers you can get. Okay, that's just for you to know as you're going around checking their answers if they want you to check their answer. Okay, but you can tell them to cover up their starting numbers. Okay, so that's fantastic. They've now got their answer. Now, one thing I would say to the class at this point is, guys, if anyone's got an answer less than 100, so if your answer only has 2 digits, can you please put a 0 in front of it? So for instance, if I got 52, make it 052. Now, what you're thinking here is if they've got 99, they're going to make it 099. Okay, so just say, okay, class, just out of interest, if anyone got an answer less than 100, can you please make sure there's a 0 in front of it? It has to have 3 digits. Okay, so now we've got our answers and we've all made sure that they've got 3 digits. Now what we're going to do is we're going to now take our answer and we're going to reverse it. Okay, so here I had 297. I'm going to reverse that and get 792. So can you please all reverse your numbers and write it beneath? Okay, and then again, you could, if you want to, get the class to check each other's. Okay, and also can just check each other's to make sure that they have reversed it correctly. Okay. Okay, the last thing we're going to do, class, is we're now going to add those two numbers together. So can you please add those two numbers together and see what you get? And now this is the point whenever they've done this, okay? So I wouldn't actually do my addition yet. I would let them do their additions. And as they're doing their additions, what they're going to notice is they're getting the same answers. They'll sort of perhaps talk about it. So, what did you get? I got 1,089. What did you get? I got 1,089. And you get that sort of little murmuring. You get these smiles between the students where they've found that they've got the same answer as each other. And it's class seeing that in terms of, them going, wow, what, you've got that, I've got that, I've got that. And then what you do is you say, okay, I'm just going to do mine. 7 plus 2 is equal to 9. 9 plus 9 is equal to 18. So carry the 1. 2 plus 7 is 9 plus 1 is equal to 10. So I've got the number 1,089. And then a lot of the people in the class will be like, wow, wow, wow. And then at that point, you could, if you wanted to, get a student up to open up the envelope and then see that inside the envelope says 1,089. And that bit actually isn't always needed. You don't necessarily need that envelope because even at this point, they're going to be sort of mesmerized by the fact that everyone's got the same answer. You might get the odd student at this point say, oh, I didn't get that. And then you know that you might need to go over and help that student. So it's quite a good activity in terms of perhaps finding out who in your class is good at additions and good at subtractions. And sort of that would be quite useful for you in terms of your assessment for learning and knowing, who do you perhaps need to help with their additions and subtractions and maybe need a bit of extra support. Okay, so then what you could do then is you can go over and have a look at theirs and you'll be able to see, did they get the right answers to subtraction quite easily, because as you know, there's only certain possible answers it would be. If that's right, check they've reversed it correctly, and then just quickly check their addition. So it's a really good one to be able to check. Oh God, guys, that might be just a coincidence. We've only chosen 30 numbers. Okay, what I would like you now to do is I would like you to choose another 3-digit number where the first digit is bigger than the last, and to try it again and see if you get the same answer. Okay, so then you can get them to try it again, and they'll find that if they choose a 3-digit number where the first digit is bigger than the last, and they reverse it and subtract it, get that answer, reverse it and add it, they'll always get 1,089. And that's fantastic. So I would use that particular lesson, that activity, a lot with primary school students. So whenever I was teaching in a secondary school, we would have done outreach. We went into our local secondary schools and tried to sell our school in terms of where the best schools to come to and so on. And I would do a math magic lesson, and this would be one of the activities I would do within that lesson. Or if I perhaps had an interview lesson where I had to choose perhaps a number topic or something, I might do something like that. But often whenever I would use this in secondary school, perhaps in first year, I would actually then take the lesson a bit further. Okay, and whenever I was doing my PGCE, that's what our university mentors done. Okay, this is fantastic with 3 digits. What about 4 digits? So with 4 digits, you could choose a 4-digit number. You could choose a 4-digit number where the first digit is bigger than the last. So perhaps something like 5, 7, 2, 1. And then you could reverse it to be 1, 2, 7, 5. And then you could subtract them, get that answer, and then reverse it and add it, and you'll find you get a particular answer. And with the 4-digit numbers, there's actually 3 different possible outcomes you can get for your final answer. You can either get, well, actually, I'll show you the 3 possible options now. So we have this one, and if we do the subtraction, we're going to get 11 take away 5 is equal to 6. 1 take away 7, we're going to need to borrow. So that's now 6 and a 1. So it's going to be 4, 4, and 4. So that's what I've got with my subtraction. Now we're going to reverse it and add it. So 6, 4, 4, 4, and then line them up and add. 6 plus 4 is equal to 10, 9, 8, and then 10. So the answer would be 10,890. So whenever we started with 5, 7, 2, 1, we've got this possible answer. So that was one possible answer. Now, what's great is whenever we've done this lesson on our PGCE, way back a long time ago, perhaps over 20 years ago now, what our course mentors done was they got an Excel spreadsheet up on the board, displayed it on the interactive whiteboard. And what they done was they sort of wrote this final answer. You got someone to write the final answer as the column, and then you put your starting number beneath it. So the students could come up, and what they'd find is you'd end up with 3 columns with the 3 possible final answers. And then as they're populating it with their starting numbers, then they'll see there's a bit of a pattern. So for instance, whenever we started with, so for instance here, one of the answers is 10890, and our starting number was 5721. It could just be written as a normal whiteboard rather than an interactive whiteboard in an Excel spreadsheet. Okay, that's our answer, and that was our start number. Okay, so now let's try another number. I'm going to show you the 3 possible outcomes here, and then I'm going to tell you the connection between the start number and the end number. Okay, so for instance, if we had 9224, that's a 4-digit number where the first digit is bigger than the last. If we reverse it, we get 4229. And then if we subtract, what do we get? Well, we're going to borrow here. So that's now 14 taken away 9 is 5. And again, remember, all this work has been done by the students. They'll be okay in terms of you say, okay, guys, I want you to now do 4-digit numbers where the first digit is bigger than the last. Reverse it, subtract it, get your answer, reverse it and add it. And then they'll be able to get these answers. So they'll just be working away on this. And you can just be going around circulating and making sure they're getting the right answers. Or perhaps those students that struggle with the 3-digit number, you can be just making sure they're okay with 3-digit ones and then get them onto the 4-digit ones. Well, hopefully while you're doing this, the students are going up to the whiteboard and they're writing their starting numbers beneath their final answers. So hopefully whenever the first few, and just say if anyone's got a different finishing answer, then just write up what your starting number was beneath it. And then you might actually be able to spot the mistakes too, because there are only 3 possible final answers for this one. Okay, so 1 take away 2, let's borrow. So that's now going to be 9, and then borrow again. So that's going to be 9, 4. So we've got 4995. When we reverse it, we get 5,994. And then when we add it, let's see what we get. So 9, 18, 19, and then 10. So that one is 10,989. So 10,989. And that was for the starting number 9224. Okay, so again, these could be as columns, and then the students are all writing their numbers. Now there'll be a connection between all their starting numbers, and then that's something that hopefully they can figure out in terms of the rule. Okay, so that was 2 of them. And then finally, if we choose a start number such as 8163, if we reverse that, 3618, and then if we subtract them, let's see what we get. We get that's equal to 4,545. And then if we reverse it and add it, let's see what we get. So 9999. So we got 9999 whenever we started with 8163. And you'll find out that all the numbers beneath 10,890 will have a 4-digit number, but the second digit will be bigger than the third digit. So here we've got 72. So if you have any 4-digit number where you've got the first digit bigger than the last, that's going to be for all of them. But here, in terms of the second digit and the third digit, the second digit will be bigger than the third digit. So all of those numbers there will have that in common. For this one here, all the 2 middle digits will be equal to each other. And for this one here, all the starting numbers beneath 9,199, the second digit will be smaller than the third digit. And that's something they'll discover. So that's fantastic. So that's one way that you can take this on a bit further. And perhaps for students in first year, that'd be quite sort of a nice investigation that they can do loads and loads of subtraction and addition. But rather than just giving them a textbook and giving them loads of subtractions and additions to work on, they're going to be working on this, doing loads and loads of subtractions and additions with borrowing, working together, sharing their answers, discovering something, and hopefully being blown away that they've got the same answer. Okay, so that's how I would often do this with first years. Okay, then in terms of taking it further, another way you could take it further, perhaps if you want to do this with maybe second years or third years, whenever they've encountered some algebra, it's actually to prove it, to use the proof as to why this is always the case. So let's have a look at that now. Okay, so we've looked at the 1089 investigation for 3-digit numbers. We've looked at it for 4-digit numbers in terms of the extension. Now let's have a look at proving it, okay? And this would be quite nice for students that have encountered algebra and you want to just sort of start introducing them into how algebra can be quite useful to show you why you get particular answers. Okay, So what I'm going to do is I'm going to say to the class, okay, we're going to use algebraic notation for our 3-digit number where the first digit is bigger than the last. So I'm going to choose A, B, C. So that's a 3-digit number where A is the digit in the first column, B is the digit in the second column, and C is the digit in the third column. Okay, now what we're going to do, we're actually just going to remember that the first digit is bigger than the last. So A is bigger than C. That's quite important. The A is always bigger than C. This digit is always bigger than this one. Okay, now what we're going to do is we're going to reverse it and see what we get. So if we reverse it, we're going to get C, B, A. So we've just reversed it. So the digit in that column and that column will switch around. Now we're going to subtract them. Well, C take away A. Well, we know that A is bigger than C, so we can't subtract here. So what we're going to need to do is we're going to borrow. So we're going to borrow 1 from here. Now this was B, the digit in that column is B. We're going to take 1 away from that. That will be B minus 1. That'd be B minus 1. And then we're taking a 10 from this column and put it into this column. So for instance, if that was 4 and we're bringing that 1 across, we then make it 14. So we're adding 10 to it. So that's going to be C plus 10. Okay, because if for instance that was 4 and you bring the 1 across, you then make it 14, and that's adding 10 onto it. Okay, now let's do the subtraction. C plus 10 take away A will be C plus 10 take away A. That's what you'd have here. Okay, now the middle column, B minus 1 take away B. Well, B minus 1 is smaller than B, so we can't do that subtraction. So we're going to need to borrow again. So we're going to cross off the A, call that A minus 1. Okay, so we've taken the 1 away from this digit. And then if, for instance, this was a 3, we then make it 13. So we're going to add 10 onto it in terms of that digit. So that was B minus 1. If you've got minus 1 and you add 10, that'll be then plus 9. So that's going to be plus 9 because you had minus 1 and you then added on 10. So for instance, if that was 5, you borrowed 1, so it became 4. And then you're adding the 10 on, and that'll be then 14. B plus 9 will be 5 plus 9, which is 14. Okay. We've then got B plus 9, take away B. I'll just leave us with the 9. So every single time we've done our subtraction, we've always had a 9 in that middle column, no matter what. And then in terms of this column here, we've then just got A minus 1, take away C. So that'd be A minus 1, take away C. And that's it. So that's what we'd get when we subtract them. Now, it looks quite complicated, but let's now reverse it and add it. You're going to find that this sort of simplifies. So let's reverse it. So that's then going to be C plus 10 minus A. We've got the 9 there, and then we've got A minus 1 minus C. And then we're going to add them together. So let's add them together and see what we get. So here we have minus A. We're adding A. Well, if you've got minus A and you add A, that becomes 0. So they cancel out. We've then got minus C plus C. Well, if you've got minus C plus C, they cancel out. And then minus 1 plus 10. Well, minus 1 plus 10 is equal to 9. So that's 9. So we'd have a 9 in that column no matter what. And then here, we've got minus A plus A. They cancel out again. Minus C plus C. They cancel out. That becomes 0. They cancel out. And then we've got minus 1 plus 1. That's equal to 0. Plus 10 is equal to 10. So that's it. That's always equal to 1089. So that's it. So you can actually go onto that algebraic proof, or even if you've got some talented students in the class in first year and second year, you could get them to consider that themselves, maybe give them some hints, or you could just show this to the class and then just show them why algebra can be quite useful to show why things might look amazing on the sort of the surface. You think, oh, well, we've always got 1089. Well, actually, it actually makes sense. We're using a bit of algebra to show that. Okay, so that's how the 1089 investigation is quite useful, particularly for primary school students. So just keeping it simple in terms of the 3-digit numbers and just going, this is fantastic, and maybe doing a bit of math magic with them on that. Then we've also got the 4-digit number investigation. That's quite good in terms of working collaboratively together with each other, maybe perhaps in groups on that. That's fantastic as well. Then also we've got the algebraic proof. Then also, I've actually been to a MAVS conference where Mark McCourt actually done this as well. And it's funny, he started this investigation. I thought, well, I've used that loads in my classroom myself. And actually what he done was he actually looked at other bases, and that was fantastic in terms of looking at what happens whenever you use other bases as well. And off the top of my head, what I think you get is if it was, for instance, base 9, you get that's equal to 1078. If it was base 8, you get that's equal to 1067, and so on. And that was really interesting to look at as well. And I think that's the case, and you might want to check that and just double check that's right. Now, I haven't actually used that one in the classroom myself, because although in Northern Ireland we use binary in terms of, and see with the GCSE maths is binary, I didn't actually go on and use it with other bases. And that might be something you do in terms of if you've got an enrichment club or something like that. So that's the 1089 investigation. I found it really, really fantastic with those younger year groups, perhaps year 7, those first lessons, or even just making subtraction and addition a bit more interesting whenever you're doing it in the classroom, because it can be quite dry in terms of here's a textbook exercise on addition and subtraction, whereas actually doing something like this just makes that addition and subtraction quite interesting. And I just really, really enjoyed it. And you have that sort of math magic link as well. And sometimes what I do is I add in some other math magic activities in with this lesson, and it just makes it really fantastic. And in terms of those other mathematical sort of activities, I'll be making another video on that as well. So as a teacher, I hope you might find this useful in terms of a suggestion, in terms of something you might try in the classroom. If you're a trainee teacher, it's just something to look at as well. And it's also quite useful if you're a home educator as well, because you might try something like this at home just with your students as well, or your child as well. And that's it. So I really hope you found this useful, and I'll see you in the next video. Cheers. Bye.